Hi guys, welcome back to my YouTube channel. So in this video, we're going to discuss another set of topic in mathematics, part 2, which is all about evaluating a function using the indicated value. So I have here 4 examples, which can be considered as moderately difficult example. So in number 1, we have here the given function. We have to evaluate the given function defined by g of x equals to 3x plus 1. So we have to find the g of x plus 1 minus gx. So the first thing that we are going to do here is that we have to find the value of the function at gx plus 1. So the value of our x will be x plus 1. Then afterwards, we have to subtract that one with g of x. So our g of x is given already. We have 3x plus 1. So if we are going to write that one, so we will have g of x plus 1 using this function. So gx plus 1, meaning to say we have to replace x in the given function with x plus 1. So we have minus g of x. So in this case, after we substitute x plus 1 from the given function, then we have to subtract the same function from the resulting function. So we have to follow this format. So is equals to, our g of x is equals to 3x plus 1. So we will get is equals to gx plus 1. So we will get 3 times x plus 1, because we are going to replace x with x plus 1 to satisfy the indicated value. So plus, from the original function, we have plus 1. Then minus our original function, which is g of x. So our value of our original function is 3x plus 1. So that is why 3x plus 1. Then simplify the result. So 3 times x plus 1, 3 times the quantity of x plus 1, that is 3x, plus 3 times 1, that is 3. Then plus 1 minus 3x. Just distribute this negative sign to the entire expression, which is 3x plus 1. So negative 3x, then negative 1 is equals to, we have to simplify. So we have 3x, we have to combine like terms. 3x minus 3x, that is 0. We have 3x minus 3x, 0. Then we have 3 plus 1, that is 4, minus 1, that is 3. So positive 3. So our value of our g, the value of the function defined by g of x plus 1 minus g of x is equals to 3. So this is now the answer. So this is how we are going to evaluate using the indicated value here. Okay, so the value is 3 using the indicated value from the original function, which is defined by g of x equals to 3x plus 1. Then we have here the second, we have to find the g of square root of 2 plus 1. So square root of 2, the quantity of square root of 2 plus 1 will be the one that we are going to replace in the x variable from the original function. So our original function, let me rewrite it again. G of x is equals to 3x plus 1. So if we are going to change x as, or replace x with square root of 2 plus 1, so we are going to change also x here. So g of square root of 2 plus 1 is equals to 3 times square root of 2 plus 1. So as you can observe here, 1 is not included in the square root symbol or in the radical symbol. So it is not part of the square root symbol. So plus, we have from the original function plus 1. So simplify the given expression. So g at square root of 2 plus 1 is equals to 3 times square root of 2, that is 3 square root of 2, plus 3 times 1, that is 3, then plus 1. So we have to simplify further. G of square root of 2 plus 1 is equals to 3 square root of 2. Then we have 3 plus 1, that is 3 plus 1, that is 4. So since we can no longer simplify this one to lowest term, and the square root of and 2 is in the radical sign inside the radical sign is not a perfect square number, so we can let this one as our final answer. So the value of the function at g square root of 2 plus 1 is equals to 3 square root of 2 plus 4. So that's it. Next, let us move to example number 2. So we have here the function given is, we have the function defined by h of x is equals to square root of 2x plus 3. And we have to find at h 2x squared. So we have to simply replace x variable from the original function with 2x squared. So it might look like this: h 2x squared is equals to the square root of 2 times our x will be replaced with 2x squared, since this is the given indicated value that we're going to evaluate. So we have to replace x with this one. So 2x squared now, x becomes 2x squared, then plus 3. As you can observe, again, 3 is not part of the square root sign or not part of the radical sign. So let us simplify further. h 2x squared is equals to square root of 2 times 2x squared, that is 4x squared plus 3. So that's it. Then simplifying further, since we can simplify square root of 4x squared further, so that is 2x squared is equals to square root of 4, that is 2, square root of x squared, that is x, then plus 3. So since this can no longer be simplified into lowest term, or there is no other simplification for this, so this is now the final answer. So that is when our x is at 2x squared. So this is the value of our function given the indicated value of 2x squared is equals to 2x plus 3. Now let us move to the second given value or indicated value. So we have here the quantity of h2 squared. So we have to write that one. So again, the function is included in the square. Okay, so squared. So the function, the original function, which is defined by hx is equals to square root of 2x plus 3. So we have to rewrite that one again so that we can avoid confusion. 2x plus 3. So this is the original composition of the function. So we have to follow this format in evaluating the given function. So we have to h of 2 or at 2 squared is equals to, we have to replace x with 2 and we have to square the entire function, the value of the function. So we have to use bracket since that is what is required in the indicated value. So the value of our function is square root of 2x plus 3 originally. Then we have to replace x with 2 to satisfy the given or the indicated value. So we have the square root of 2 times 2. Since the indicated value for the x in the original composition of the function is 2, so we have to replace x with 2, then plus 3. Then the entire function should be squared as to satisfy the given indicated value. So now let us proceed, simplify. So we have here 2 times, so 2 square root of 2 times 2, that is 4, then plus 3, then squared. Okay, sorry for this. This is parenthesis. Okay, so let us continue. H of 2 squared is equals to square root of 4. We have square root of 4, that is 2, then plus 3, then squared. Then we have h2 squared is equals to 2 plus 3, that is 5, then squared. So the final answer might be 5 squared, that is 25. So our original function defined by h of x is equals to square root of 2x plus 3, evaluated using the indicated value of the square root, the quantity of h of 2 squared is equals to 25. So this is the final answer. So let us proceed to number 3, example number 3. So this is quite complicated example compared to our previous video or previous examples in our previous video. So we have here f, we are going to use two variables in one function. So we have function of xy is equals to x minus y over x plus y. So we have to find the value of the function, original function, by evaluating using 2x minus 3, x plus 2y. So this 2x minus 3 is the value of our x here, and our value of our y is x plus 2y. So these are the values that we're going to replace in the original formation, composition of the function. So we have our x is 2x minus 3 and our y is x plus 2y. So the resulting will be, our x will be replaced with 2x minus y, 2x minus 3, then minus, our y will be x plus 2y, x plus 2y, all over our x, again substitute 2x minus 3 plus our y is x plus 2y. Then simplify further. So we have 2x minus 3 minus x. So it will become 2x minus 3 minus x minus 2y. Just simply distribute the negative sign to the expression, which is x plus 2y. Then all over the denominator, we have 2x minus 3 plus x plus 2y. So combine like terms, we have 2x minus 3 minus x minus 2y, that will become 2x minus x, that will be x. Then since negative 2y has no other term other than negative 2y, so just copy that one, negative 2y. Then we have negative 3 also. Then for the denominator, we have 2x minus 3 plus x plus 2y. So we have common 2x and x, that will become 3x. Then just copy positive 2y and negative 3 or minus 3. So since this can no longer be simplified into lowest term, or this can no longer be simplified, now this is the final answer. So our value of the function defined by fxy is equals to x minus y over x plus y, as evaluated using the indicated value, which is this one, is equals to x minus 2y minus 3 all over 3x plus 2y minus 3. So that's it. Let us proceed for the second indicated value using the same function, which is this one. So we have the second will be f, the value of your x will be y plus 2 and the value of your y will be x minus 5. So it is transitive, or it is reverse. Okay, so we have to write again the original function to avoid confusion. X minus y all over x plus y. So we have to substitute the given values. We have y plus 2, and we have x minus 5. This is not included. Okay, so it's equals to, our x will be y plus 2. So this is our x and this is our y. So our x in this expression or function is y plus 2, then minus our y is x minus 5 all over our x is y plus 2 plus our y is x minus 5. So simplify further. So y plus 2 minus, distribute the negative sign, it will become negative x, positive 5, the same with the denominator, plus 2 plus x minus 5. So we have to combine like terms. So our like term in the numerator is 2 and 5. So we have negative x. Sorry for that. Okay, so negative x plus y. So 2 plus 5, that is 7, positive 7. So on the denominator will be, we have common, which is 2 and negative 5. So we have to combine that one. So x plus y minus 3, since positive 2 minus 5, that is negative 3. So since the resulting expression can no longer be simplified into lowest term, so this is now the final answer. So our function defined by f of xy is equals to x minus y over x plus y, which is the original given function, evaluated at the indicated value of y plus 2x minus 5, the result will be negative x plus y plus 7 all over x plus y minus 3. So that's it. Okay, so let us move to example number 4. So we have here the given function is h ab is equals to a squared minus b squared. Then we have to find a plus b, a minus b of the function. So maybe I forgot to write h here. Yes. So h at a plus b, a minus b. So just directly substitute these values to the original function. So we have our a is a plus b, and our b now is equals to a minus b. So we have to substitute a plus b squared minus a minus b squared. So this is the value of our a, and this is the value of our b. That is why we replace a with a plus b and b with a minus b. So we can have this one, we have to expand this one to simplify the given to find the exact value of the function being evaluated. So we have, this is the square of a binomial, so the rule is square the first term, twice the product of the first and the second term. So twice the product of the first and the second. So first term is a and second term is b. Then twice, that is why 2ab. Then square the last term, that is why it become b squared. Then minus, in the second expression we have square the first term, twice the product of the first and the second term, then squared the last term, it become b squared. So combining like terms, we have a squared. Okay, let us simplify further. 2ab plus b squared minus a squared. Just distribute negative sign to the entire expression here. So positive 2ab minus b squared. So the remaining will be a squared minus a squared, that it will be cancelled out. Then we have 2ab plus 2ab, that will become 4ab. Then we have b squared minus b squared, that will be cancelled out. So the value of the function originally HAB is equals to a squared minus b squared, as indicated, evaluated by using the indicated value of HA plus b, a minus b is equals to 4ab. So this is now the final answer for after we evaluated using a plus b, a plus b, a minus b. So that's it. That's all for this video. I hope you learned something from the explanation based on my capacity to explain the concept on how to evaluate function. God bless everyone, and thank you for watching.